Okay, question 12 from the geometry says to write a two-column proof, and as you can see, I've copied over the diagram given and also given information of what we're trying to prove. If you look at the last line, what we're trying to prove triangles congruent. With that being said, our options are going to be side, 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 or side, angle, side. Those are the two that we know right now. The other one we know is definition of congruency, but now that we know our shortcuts, we're not going to go back to the definition of congruency. So, looking at what we've been given, we have that side or line segment AD is congruent to line segment CB, so we have a side congruency statement or segment congruency statement. So looking down here, we need an angle and a side congruency statement or two more sides. Now, the other piece of given information, very important, we see that line segment AD is parallel to line segment CB. Remember, when we see parallel, okay, we go back to chapter 3 with our special angle pairs. And we know that if lines are parallel, that alternate interior angles, alternate exterior angles, and corresponding angles are congruent. Looking here at our lines in our transversal, we have line segment AD parallel to line segment CB, and here's our transversal. What we can do is we can go ahead and drop in a 1 and a 2 here, instead of having to use the 3 points to name this angle. And the reason I put them here and not here and here is keep in mind that these are the two lines that are parallel. So if you look at this angle 2, which is angle BCA, it's made up of one of the parallel lines and the transversal, and angle 1 or angle DAC is made up of the other parallel line and the same transversal. If we were to put the 1 over here, we're using the transversal, we're using a line that we do not know to be parallel to DC. So that's why I put them there. So there we can say that angle 1 is congruent to angle 2 because those are alternate interior angles, and that would be the alternate interior angles theorem because we knew that the lines were parallel and concluded this. So now we have an angle statement and we need a side statement. The reason I say we need a side statement is we need side, angle, side because these are the two congruency postulates that we know for triangles, at least as shortcuts. So we know if we use side, angle, then we're going to need another side. And looking here, when you go back to segment congruency or side congruency, the two options we have are definition of midpoint, which we don't have here, or the reflexive property. And the reflexive property states here that something is equal to itself, that the exact same segment or exact same angle is equal to itself. So that side would have to be present in both triangles. And if you look at the diagram here, this side AC is a side in both triangles. Or if you look down here, AC, AC, or CA, okay, both of those sides appear there as well. So what we can say is we can say that line segment AC is congruent to line segment AC by the reflexive property. And that's another side statement. So now that we have side, angle, side, okay, in that order, side, angle, side, side, angle, side. Remember, using side, angle, side, the angle has to be the included angle or the angle between the two sides, which really I guess we would consider kind of the vertex angle. So that's what we have here. It all matches up. So in fact, we know the triangle ABC is congruent to triangle CDA by the side, angle, side congruency theorem. And that's how you would prove, or one way of proving question number 12.